LLM, large language model, right? So let's try to understand what exactly is large language model. So large language model, before understanding that, we need to understand exactly this part, language models, right? So this is more important, and then we can understand the why we call it as a large language model, right? So here is the language model. A model that understands means it can understand the English sentences, whatever the text that we have given. It can understand the grammar and everything, whatever is present in that. And then it can generate similar to that, right? So if it can understand the sentences, the words, the character, the letters, and it can generate or it can predict the text, right? Prediction means generating at all, right? So any model, right? If we can ask the model that this is my text, you need to understand this and summarize this. You need to understand this and you need to give me the next sentence or the next word that we can show to the users. So that will be called as a language model. So before LLM also we had the language models, right? But after the introduction of LLM, the large language model, two things changed there, right? So we started calling it as a large language model because of the two major factors. The first is large data set for the training. So we started training the language model with a large data set, means everything present on the internet. So we feeded all the data present on the internet into the language model, and because of that, there is something called parameters, weights that come out from the model when we train the model. So for now, that is only important to understand that there will be a model.py. We will feed the large data set for the training purpose, and that model.py will output some numbers, right? And that numbers will be huge in terms of magnitude, right? So large model size means large number of parameters will come out after the training process. So because of two reasons, we call the language model as a large language model. Large data set on which it has been trained, and after the training process it is going to output you the large number of parameters, right? Those are numbers, 1 2 3, something like that, right? So just for now assume that they are numbers and they are stored in a file, right? Now, so something like this it will look like. So there will be a model.py. In that we can use some architecture like transformer architecture because they are famous right now, but that is not compulsory. Any architecture might come in the future as well, so we can do that as well, right? So for now just understand that we will have a model.py, and in that we will have 500 or 400 or 200 lines of code, right? And that code will be written by the machine learning engineers, right? Now in this model we are going to feed a large data set. We are going to feed a large data set, and somehow this model will output parameters.bin, a file, and in this file we will have a huge magnitude of numbers, right? So many numbers will be feeded in that, right? And because of that reason, m- maybe the file size will be 400 GB, right? So that can come out. So if you see that, right? So large data set and large number of parameters getting stored in a parameters.bin, right? So that is what we call it as a large language model, and this we call it as a foundation based model. So companies like OpenAI has released some of the open source model. So effectively they release two things. So if you see any model getting released on the internet as open source, right? So everyone talk about the weights, that weights are the gold, that is something we want, right? So if someone asks me today, you want data or you want parameters.bin, so I will say parameters.bin, simply because if I have the data and if I have this as well, right? So this is also something, most of the things are publicly available on the internet, model.py, right? So if I have this and if I have this, I will need $100 million to train because I need the GPU of that level, right? So I cannot invest that much amount in that, right? So if someone asks me that what do you want, right? So I will say just give me this and this. That's it. I will not want this and this because I will have to invest to create this. So these numbers are actually gold. So that is why if any company is open sourcing, for example, Elon Musk Grok AI company, right? So they have released some Grok model which is open source. So effectively they have released two things, model.py and this parameters.bin. So in this the numbers are which are gold for all of us, right? So that is something they have released. and that we will call it as a foundation based model. So same thing, we will try to understand what exactly are stored in the that parameters.bin, right? So for that, let's try to understand this. So let's say we have the data set like this, as you can see on the screen. So these are the data sets for the real estate agent. So we'll try to understand this from the real estate agent, that what exactly is those parameters weights which are stored inside the parameters.bin, right? So that I will help you understand. So you can see this example that we have the number of bedrooms, square feet, balcony, and the price. So these are the previous deal some real estate agent has done, right? So this is the input and this is the output. If someone has bought this 2 bedroom, square feet, balcony one, so they have charged something like this, right? So from the previous deals, they know that something like this our data set look like, right? Now, what the real estate agent can do, they can create a model in which they can write price is equal to w1 into bedroom, so there will be a multiplier for the bedroom, right? Similarly, there will be a multiplier for the square feet. Similarly, there will be a multiplier for the balcony as well, right? So w1, w2, and the w3 are the multiplier, and they are the weights actually. So what will happen here is that from the previous deal, somehow we will be able to infer that based on the experience, that for this data set we had these outputs. So these were the inputs and these were the output for those data set. So by seeing all this data, by doing some calculation, mathematical calculation, we can infer that w1 will come out something like this after the training process. So we will feed all this data into the model.py, which is here real estate agent model, right? So here we will feed all this data, w1, w2, w3 will come out from that after feeding all this data. So you can think of like that, from the experience, right? People will be able to infer what is the value of w1, w2, w3. So after some experience, after some training, we will come to know that the value of w1 is this, the value of w2 is this, and the value of w3 is this after some training process, right? So that is something is not important to understand as of now. Just understand that after some experience, after some training process, this model.py will output w1, w2, w3. Now, if anyone asks the new output, right? So if someone gives you the new input, right, and they are asking for the new output, so they can give you something like this, right? So they can give you something like this. Now we need to predict the price. So what we will do is that we will take the model, and our model is this effectively, right? Now after the training process, we have what? W1, W2, W3, and that can be retrieved again and again from the parameters.bin. We don't have to read it again and again because we have first trained the model and saved all the parameters, all the weights inside the parameters.bin. So now we can read from here and load this equation, and simply we can feed number of bedroom, square feet, and the balcony here, here, and here, right? And we will get the output like this. So weights are those numbers which we get after the training process. So similarly in the large language model, right, large language model, we get all those weights w1, w2, w3. So your model.py will look like something like this. So you will have the model.py, just the pseudocode I have written here to just help you understand what happens in this model.py. So you write some code like this. For example, you have only three weights, right? W1, W2, W3. So you initialize the weights with 0, 0, 0, something like that. And then you write some architecture, some code. Not important to understand what is written here. Just for understanding purpose, I have written that you understand that there will be a weights in the architecture model.py written, and then we will load the model, and we will say, okay, let's initialize the weights with 0, 0, 0, and feed the data into the model somehow, right? And then the weights will come from the training process, some value of w1, some value of w2, and some value of w3. So like that we will get. So first we initialize with 0, 0, 0, and after that we get, after the training process, some real good optimized value of w1, w2, w3, right? And then we save to a file parameters.bin. So those numbers are saved in the parameters.bin in this model that I have shown you. Now, when we have to predict, so simply we will load the file, and from there we will read the weights, and then we will ask the model, hey model, you take this weights and you also take the input that user has given, right? The number of bedroom, balcony, and the square feet. So those things we are going to feed into the model, and then we will get the output like this. So this is the output for that, right? So something like this model.py looks like for the large language model as well. So the major difference will be that instead of only two weights, three weights, right? Those weights will be in the magnitude of millions or the billions as well, right? So that is the major difference between what I have shown here and what would be present inside the large language model model.py, right? So here for the simplicity, I have shown only three weights, right? But in the large language model, you will have billions, millions in that magnitude, right? So now let's try to understand why I mentioned 400 GB, right? So that is called model size. So model size I mentioned 400 GB. So I'll help you understand this. So for example, we have 100 billion weights present in the parameters.bin. I'm not talking about W1, W2, W3. I'm talking about W1, W2, W3 to 100 billionth W, right? So that is the thing that happens in the large language model. It will be in 100 billion, 100 billion, 100 million, like that magnitude, right? So let's take the example of 100 billion. So in the 100 billions parameter, when you have 100 billions numbers stored in the parameters.bin, right, that file will become huge. And how do we calculate the model size? Like this. So we say that number of parameters, that is effectively here 100 billion, and we multiply with the bytes per parameter. So let's say we have the floating point 32 bit, right? So our one number will look something like this. And if you consider 16 bit, right, so here we have 32 bit and here we have the 16 bit. So based on the precision, if you see this, right, so if you consider 32 bit, this number has more precision than what you can see in the 16 bit. So if you want to decrease the model size, you will go with the lower precision. Obviously it will have the less accuracy, but let's try to understand with this example. So we will have 32 bit higher precision in this case. So each number will look like this. Each number will look like this. So if you have 32 bits, 32 bits means how many bytes? 4 bytes, right? 32 bits means 4 bytes. So one number that is present in the parameters.bin will take 4 bytes of memory. And when you have 100 billion, right? So like this we can calculate 100 billions with 32 bits, right? So 1 byte is equal to 8 bits. So 100 billion will come something like this. So you have 100 billion parameters, numbers stored, each one is 4 bytes. So if you calculate, ultimately you get 400 GB. So when someone says that I have a model of 100 billion parameter, 32 bit, you can simply say that that will take 400 GB on a machine when you are going to have that, right? So that is a 400 GB for this. Now if you talk about this 16 bit, right, if you talk about this 16 bit, right, so that will be half of the 32 bit, because it will take only 2 bytes, and if it is taking only 2 bytes, that is going to take 200 GB. So we can decrease the model size, we can decrease the precision, we can decrease the accuracy to make it workable on a machine where we don't have the 400 GB of the capability, right? So like that we can decrease the model size. So like this it happens actually. So now when I say large language model, so you don't need the internet, you don't need anything as such. So just see this PPT. This is very important. We need to understand what I have mentioned here. Hmm. So this is something is important for us to understand. Running the model, and here in red letters I have written that it works completely offline without the internet. And this is something, a magical thing we need to understand, right? And actually this is not a magic, right? So if you have your laptop, right, if you have your laptop, you can download the open source model, right, present on the internet, and you will effectively download two things, right? You will effectively download only two things. One is model.py, in which code will be written to load the parameters.bin and make the object of the model, and you can feed the data in input for the prediction, because they have already trained with the data. Now we don't need to feed the data, we need to feed the input for the prediction, right? So anything present on the internet as a open source large language model, you can simply download that, and you can keep those two files on your machine locally, right? So what will you do? So for example, you can download the model which is of 10 GB, 5 GB, 3 GB, 2 GB, 20 GB, like that, based on your machine capability, right? So for example, here we have the model.py and we have parameters.bin. So two files you will download, model.py and the parameters.bin, effectively, right? Now this is a directory on your laptop, this is a directory, and in that folder you will have model.py and the parameters.bin. That's it. And now you switch off your internet, right? No need of internet at all. Now if you say he is a good, right, so somehow the model has been trained on the large data set, so it has captured, learned so many information from the internet, so that it can give you this prediction. So it doesn't need any internet at all, right? That is very, very important for all of us to understand, that large language model works completely offline, right? So there is no need for the language model, and in fact language model is like a kid, right? So you have taught them something, right, a kid, and now the kid is present in a closed room and there's no access to the internet, and that is something we have to think as an LLM, right? It means that the LLM cannot make a network call. So there is a common misconception on the internet I have seen. LLM makes the network call, right? That is a complete wrong statement, completely incorrect statement, right? LLM is simply what? Model.py and parameters.bin present in a directory. By having the Python, you can simply run Python space model.py and ask he is a good. It can give you is a good boy, right? Simply. So it can run completely offline. That is very, very important for all of us to understand. And large language model only does what? It understand the language, it understand the sentences, and it can do something for you like summarize, predict. So like that it can do. No, it cannot make a network call for all of you. It cannot do any other things. It can only understand the language. Just like a kid, if you have taught English language to the kid will be able to interact with you in the English, right? Kid will not be able to use the mobile devices and go and do something on the internet, right? He or she can only communicate with you. He or she can simply mimic what you are saying. So those things completely LLM can do. So from now onwards, you all have to think that LLM is a directory. In that you have model.py and the parameters.bin. That's it. And it can completely work offline without the internet, right? So that is the capability of the LLM. So now some maths numbers, some magical things is done internally. So that I cover in the classes when I do for the outcome school. Now, effectively, what is happening here, right? So first you give what? He is a good, right? So internally it tokenizes. So you can just consider that a machine only understand the numbers. A machine cannot understand text format, right? It can understand only numbers. So you will have a mapper file. So for example, you have the mapping, hash map, table, dictionary, like that. In that you have stored 12 means he, 7 means is, 5 means a, and 42 means good, like that, right? And that is called tokenization in some way, right? So converting a text into the number, because the machine, the language model understand the numbers in a better way for the mathematical calculation, right? It has to perform some operation to give you the output, right? So plus and minus, it has to do the multiplication and so on, so some mathematical operation. So because of that, it has to be converted into the number format. So this is how we simply do this. We convert this into the number format, the tokenization process, right? Then there is something called embedding. So you can check on my YouTube channel what are embeddings. For now, that is not important. It is just that we convert this scalar number into some n dimensional array, right? So this is something 3 dimension it has, right? So again into the numbers, and these numbers again represents what? This represent he, this represent is, and so on. So and finally we feed this to the model. So these are effectively done in this directory only. I have just shown by expanding that so that you understand. Model understand numbers, model doesn't understand the text format. So we need to map the text into the number. And again model will output what? Everyone say at your end, model will output again once again the numbers, and that again in the vector format. And now what we will do, we will reverse of the embedding will be done, and again we will have something like this. So now in the mapping file we have written that okay, 55 means boy, 42 means good, right? So we will reverse of the tokenization will be done, and then we will get is a good boy. And this is how the large language model works internally. So we feed the number, we get the number, and we remap using the mapping file that we have from number to text. And this is what everyone is doing internally, ChatGPT, Gemini, whatever the models we have on the internet.